So we will get started. Again, this is our second webinar of the day. This one is on the Whiteshell Laboratories Restoration Project, Low-Level Waste Trenches Remediation Update. I would like to acknowledge that Whiteshell Laboratories is situated on the traditional lands of Treaties 1 and 3 and near Treaty 5. This land is the home of the Anishinaabe, Ojibwe Anishinaabe, and the national homeland of the Red River Métis. We recognize that many other Indigenous peoples across the region in Canada also consider this area their home. CNL is deeply grateful for the opportunity to work on these lands and waterways, which hold significant cultural and historical importance. We acknowledge that this site was established without consultation with the Indigenous peoples of this area. We recognize the ongoing impact of this, and we are committed to understanding and respecting the unique Indigenous history, rights, and title associated with this land. So before we kick off today, there is simultaneous interpretation. So if you'd like to hear this in French, please select the globe icon on the bottom right on the bar on Zoom. Today's session is planned for about 45 minutes with presentation and Q&A. Please use the Q&A icon to ask your questions at any time, and we'll take them up at the end. We do record these sessions because we like to post on YouTube afterwards. And we also will send a link to all participants with an email with a YouTube link with also answers to questions that are either too technical to answer today or we don't get to them. If you have any technical issues, please email wlcommunications@cnl.ca. Our team will be watching the inbox, so we'll get you sorted out. We're also looking to evaluate our webinars more in depth. So there is a short 10-question survey that we'll be sending after the webinar. We'd really appreciate it if you take the time to share your thoughts. Today's webinar, you'll be hearing from Alan Caron, Director of End State Strategy at Whiteshell. Alan will be providing us with an overview of the most recent updates on the low-level waste trenches remediation. After his presentation, we'll open the floor to Q&A. So Alan, over to you.
Thanks, Mike, and hope everybody can hear me fine. But welcome to the Whiteshell Laboratories Restoration Project's update on the low-level waste trenches remediation. It's a pleasure for me to be with you today as I share this update with you. My name is Alan Caron. I'm the Director of End State Strategy at the Whiteshell site. I've been at Whiteshell for 16 years and have enjoyed living in eastern Manitoba with my family over that time. Next slide, please. Over the next 20 or so minutes, I will be giving a quick overview of the low-level waste trenches cleanup options at the Whiteshell Laboratories site. Our aim is to provide a relevant and understandable explanation for everyone, whether you've been following the cleanup of the Whiteshell site for a while now, or are newer to the project. Today, we'll be covering a number of topics related to the low-level waste trenches at the Whiteshell site. Included will be a short overview of the Whiteshell site itself, followed by a brief definition of what is nuclear waste. Then we will be getting a brief overview of the low-level waste trenches themselves, as well as different remediation options that we are exploring. We will then provide a brief overview of the environmental monitoring that is focused at the Whiteshell Waste Management area. And then I would like to hear and respond to any questions that you might have. Next slide, please. To kick things off, particularly for those who are new to our work, we like to share a brief overview of the Whiteshell Laboratories Restoration Project. And for those who are familiar, this may seem to be like a bit of a refresher. Next slide, please. The Whiteshell Laboratories was built in the early 1960s by Atomic Energy of Canada Limited as part of Canada's commitment to advancing the safe research of nuclear technologies. At its peak in the 1970s and 1980s, the site had over 1,000 employees who were involved with many research programs whose findings are still benefiting the world today. Those included developing designs for reactor fuels, reactor safety systems, and the safe storage of spent nuclear fuels. The WR1 reactor operated for just over 19 years from 1965 to 1985, and it was the centerpiece of the facility. In the mid-1990s, the Government of Canada made the decision to cease operation of the site and begin planning for its decommissioning. A number of key research programs were relocated to our headquarters in Chalk River, Ontario. The Whiteshell site is located about 100 kilometers east of Winnipeg, Manitoba, and covers roughly 11,000 acres, or 4,400 hectares. It's important to acknowledge that the site was established without consultation or agreement from Indigenous nations at the time. Next slide, please. CNL is committed to protecting the environment by safely cleaning up Canada's nuclear legacy sites, including the work that we're doing at the Whiteshell Laboratories Restoration Project, or WLRP. The Whiteshell Laboratories project is the first large-scale cleanup of a nuclear site in Canada, marking an important step forward for CNL and the country. Our goal is to safely complete the decommissioning and return the site to a condition that will remain safe for people and the environment for generations to come. We apply the most up-to-date best practices to clean up buildings, affected lands, and legacy waste, with a strong focus on protecting employees, the public, Indigenous nations, local communities, and the environment. To ensure our work has no negative impact, we have an extensive environmental monitoring program in place that tracks conditions before, during, and after cleanup activities. To make this happen, we have a clear plan in place that outlines exactly how the site will be cleaned up and restored so that it stays safe for people, wildlife, and the environment, now and into the future. Everything we do is carefully regulated by the Canadian Nuclear Safety Commission, or the CNSC, which ensures our work meets strict safety and environmental standards. Okay. The site restoration plan describes how we will safely remediate the Whiteshell site and prepare the land for future use. The plan breaks the site into different sections that are based on the activities that took place and defines the remediation for each area to keep people, wildlife, and environment safe. Successfully completing the low-level waste trenches project is a critical step to bring the site to closure. In the end, about 10,800 acres, a vast majority of the site, will be available for community, cultural, or economic opportunities as unrestricted. Less than 1% will remain, or we propose to remain, under institutional control for long-term monitoring and care. If you'd like to learn more about the plan, we will drop a link into the chat and then to another webinar you can view at your leisure. Much of the research that I described earlier was focused on the main campus. Another key area of the site is known as the waste management area. The waste management area is located about 1 kilometer from the main campus and is designed to safely store low-level and intermediate-level radioactive wastes, with our concrete canister storage facility adjacent to it, but is not officially considered part of the waste management area. It was built in the 1960s, the same time as the rest of the site, and it was to handle, it handles waste generated by the laboratory's innovative nuclear research and development work. The area includes several types of structures that include in-ground low-level waste trenches, low-level waste bunkers, standpipes, and intermediate level waste bunkers, storage quonsets, and a cask loading facility that is currently being repurposed. The waste management area is a key focus of the overall site cleanup plan, ensuring that all waste is managed responsibly and in line with modern safety standards. Understanding this area helps explain why projects like the low-level waste trenches cleanup is so important for safely closing and restoring the site. Though about a kilometer away from the main campus, the waste management area is located within the site boundary of the Whiteshell Laboratories. The aerial photo shows how the area contains all three different levels of waste generated from the decades of research and operations. For this webinar, our main focus is on the low-level waste trenches, which you can see on the right, on the drawing on the right, highlighted by the blue rectangles. The photo on the left is an aerial shot of the waste management area, and you can see that those trenches are actually underground and covered by the green grassy area you see on the surface today. Now that we've looked at where the waste is stored at the Whiteshell site, you might be wondering, what exactly are we managing there? The nuclear waste itself. It's a broad subject. I'd like to take a moment to explain the types of nuclear waste that we have at Whiteshell and what that actually means. Nuclear waste is somewhat of a mystery to many people, so let's shed a little bit of light on that. Nuclear or radioactive waste is a byproduct that comes from the operation of nuclear reactors or processing nuclear fuels, conducting medical treatments in hospitals, and research work. Waste is also generated when we decommission and dismantle reactors and other nuclear structures, which is exactly what's happening at Whiteshell right now. We classify nuclear waste into three main types: high level, intermediate level, and low level. High level waste is mainly comprised of used nuclear fuel that has produced energy inside a reactor. At Whiteshell, this type of waste is securely stored in what's called a concrete canister storage facility. The picture on the left is not from Whiteshell, but is representative of how nuclear fuel is safely stored. Intermediate level waste includes things like laboratory waste, contaminated equipment, or protective clothing that has higher levels of contamination on them and needs to be isolated for a longer period, usually several hundred years. At Whiteshell, intermediate level waste is stored safely in standpipes and intermediate level waste bunkers within the waste management area. The picture on the right is not from Whiteshell, but is representative of how intermediate level waste is safely stored. In both the cases of the high level and intermediate level wastes, CNL has plans to retrieve that waste in the next upcoming years for safe storage and eventual safe disposal. Low-level waste is probably the easiest type to picture because it often looks like everyday garbage. This includes things like used gloves, boots, protective shoe covers, clothing, cleaning rags, mops, equipment, and tools. All items that may have come into contact with radioactive materials during normal laboratory work, maintenance, or cleanup of minor contamination. These materials pick up very low levels of radioactivity and generally have short decay periods, meaning their radioactivity naturally decreases over time, usually within a few hundred years. Even though this radioactivity is low, it still needs to be managed safely. So at Whiteshell, this type of waste is stored in specifically designed low-level waste trenches and above ground bunkers within the waste management area. And so I think you can see the nuclear waste isn't what maybe many people imagine. In all my years of site, I still haven't seen anything green and oozing. But while it may look ordinary, all of this waste must be managed with great care. The radioactivity in these materials will decay over time, but it will take several hundred years. Our job is to keep all living things safe while the processing is underway. That means handling waste safely and keeping it properly contained and isolated to prevent the spread of contamination. Now that we have a better sense of what low-level waste actually is, let's take a closer look at what safely managing and storing it. One of the ways we are safely storing this type of waste on the site is through low-level waste trenches. These trenches have been an important part of safely containing low-level waste for decades, and they're a major focus of our site restoration mission. Here are some quick facts about the trenches at the Whiteshell site. The trenches operated from the mid-1960s to 1985. We have 25 of them in total, and they were dug into the natural clay using a backhoe. Other than the natural clay, there was no other kind of lining installed. The design was based on widely accepted practices for similar trenches around the world, including our main site at Chalk River. Around the world, there are 80 other similar trenches installations. 21 of the 25 were identified in the 2002 environmental assessment as being suitable for in situ disposal, pending a final safety case. I'll get into a little bit more about what in situ disposal really means a little bit later. These trenches contain low-level waste like the rags, the mops, the tools, Tyvek white paper, Tyvek suits and booties worn by employees that worked in contaminated areas. Anything else that has been contaminated by coming into contact with radioactive materials. But we also include some hazardous wastes or hazardous materials like chemicals and solvents were also placed in the trenches, as well as in some cases contaminated soils. Most of this waste came directly from the Whiteshell Laboratories operations, but waste was also accepted from a few other provincial sources. For example, chemicals from Manitoba Agriculture and an old Manitoba radium facility that operated years ago. What is not in the 21 trenches is intermediate level waste, as I mentioned before, which is currently safely stored in the bunkers and standpipes, or high level waste that is safely stored in our concrete canisters. We do have plans to remove all of that waste and safely store it and dispose of it elsewhere. The low-level waste trenches at the Whiteshell site contain about 80,000 individual waste packages. A vast majority, about 96% of them, are bagged, could be paper, plastic, or burlap, which were common packaging materials back then. Another 3% of the waste are in drums, and the rest are in boxes and cans, and even some retired tools and equipment. When these trenches were first used, they followed the standard waste disposal methods of the day. Waste was typically loaded into trenches using front-end loaders, and at the time, future retrieval was not part of the plan. Today, our restoration plan takes this legacy into account. Some of this material will remain safely contained underground with protective covers, undergoing monitoring to ensure safety for people in the environment. While detailed records were maintained at the time, we have identified some inconsistencies between what was recorded and what we verified during site assessments. Our restoration plan accounts for these gaps to ensure safe cleanup. Each trench is about 4 meters deep and well within the clay layer. And then when they were closed, was covered with clay. Oh, if we go to maybe the previous slide there, sorry. Yep. The picture on the right are from the waste emplacements. It may be a bit shocking to see, but again, these were common practice worldwide at the time. Okay, now the next slide. The hydrogeology of this area is an important factor. Extensive studies have indicated that the heavy clay content of the soil provides a good natural barrier against movement of contaminants. Also, the groundwater flow is primarily upward in the area of the waste management area, which minimizes the potential for contaminants that migrate out of the area. The location of the waste management area was purposely chosen because of the combination of the natural clay and water table. Though this slide may be tough to read, but the picture is an east-west cross-section of the land that includes the waste management area, and that is the little area where the red writing is. Many of us think that the land in Manitoba is flat, but there is a gentle east to west gradient that causes groundwater to discharge in this area, and that's all indicated by the arrows. A few slides ago, I described the trench's contents being mostly bagged waste. We know that this waste is in direct contact with the surrounding clays, and those clays are impacted. Based on estimates there is more impacted soils and clays than the waste that was actually emplaced in the first place. By our estimates, most of it, about 83%, is impacted soil, with about 15% being the original waste material. This is a key slide to remember for later, a little bit later in the presentation. To get an idea of the total volume of waste, we have an estimate of about 30,000 cubic meters, and that includes the waste and impacted soils. To get a picture of what that would look like, that's a CFL football field with 2.5 meters of materials on top. We know that there is no existing disposal site in Canada that could accept that amount of waste from the Whiteshell site. Okay, next slide, please. A few slides ago, I mentioned that the trenches operated from the mid-60s to 1985. And the trenches was common practice for waste disposal around the world. In our case, the trenches were dug 4 meters into the clay, ensuring that there was a good barrier all around to prevent outward migration of contaminants. When the trenches were deemed to be full, or they were capped with the same soil. In the mid-1980s, as better waste storage methods became available, Whiteshell transitioned from using the in-ground trenches to storing waste in secure above-ground concrete bunkers, much like you see on the right. So both pictures are from Whiteshell. This evolution shows how our thinking and practices have progressed over time, ensuring how we handle waste with the utmost safety and care. Okay, next slide, please. Okay. In 2023, CNL started engaging with rights holders, stakeholders, and the community to discuss the available remediation options for the low-level waste trenches. This dialogue is an important step to ensure we choose an approach that aligns with updated regulations and meets our commitment to safety and environmental stewardship. Back in 2002, when we received regulatory approval to proceed with the cleanup at the Whiteshell site, we proposed that the trenches be left in place with additional barriers, with required additional barriers to ensure the waste and contamination stays in place. This is called in situ disposal, and has been widely used in similar facilities in Canada and the US and around the world. The environmental assessment at the time was on side with this approach, provided we prove that the methods we choose is safe and meets current regulations. In 2021, an updated set of regulations came into force, making this approach less feasible. Under the changes, it would be mandatory to install multiple engineered barriers to protect the surrounding environment. This compelled us to look at other options and have continued engagements with Indigenous nations and the public since 2023. Now that we've covered the history of the trenches and how our waste management practices have evolved over time, I want to take a moment to add some important context before we talk about the options we're considering for the trenches today. To do that, it helps to explain the term in situ disposal. In situ means we manage certain waste by leaving it safely in its original location rather than digging it up and moving it elsewhere. To make sure it is safe, we would make specific modifications to the site or the multiple engineered barriers I mentioned earlier. This could mean adding protective covers or barriers that would keep the waste secure and stable for the long term. These measures help prevent any contaminants from moving outside from this waste management area. For Whiteshell, there are several ways to add engineered barriers that each pose their unique challenges. They would include, building a submerged wall around the entire waste management area by digging a trench and filling it with engineered clay. The picture is elsewhere putting in one of these grout walls. Another way would be to add a barrier called a geomembrane between the waste and the natural clay underneath. In simple terms, a geomembrane is a synthetic liner that blocks moisture from moving in or out. We would likely also need to install an engineered cap over the entire waste management area to guide water runoff from entering. These are just a few examples that would likely need to be added to meet regulatory approval. Though in situ disposal is technically feasible, C&L began to evaluate other options that would still effectively protect the environment and the surrounding communities for the duration. So the option number one that we've been exploring is still in situ disposal. As just mentioned, in situ disposal is still technically feasible and is the approved methodology under our 2002 environmental assessment. Out of the 25 trenches, 4 were identified as unsuitable for long-term in situ disposal. For these, the plan is to fully remove the waste and safely transport it elsewhere for proper disposal. For the remaining 21 trenches, we would need to add the multiple engineered barriers I just spoke about to meet today's strict regulatory requirements and to protect the people and environment for the long term. Even with these engineered barriers in place, enhanced environmental monitoring would likely be required at least for 100 years to ensure the site remains safe and secure. Another option we've been evaluating is complete removal of all trenches waste, and that includes the impacted soils and clays. We would then backfill the voids and grade the area. All of this material would need to be shipped off-site and would likely be to another C&L site like Chalk River, Ontario. We estimate and recall 30,000 cubic meters of waste, which would take roughly 3,000 semi-truck loads to transport the multiple thousand kilometers to the Chalk River site. However, the one major issue with this option, the volume of waste well exceeds what any existing or future facilities are allowed to store. There are plans to expand the Chalk River capabilities for low-level waste in the future, but even then, this volume exceeds what will be allowed, and by quite a bit. Indigenous nations in the Chalk River area would also need consent before this much waste could be shipped and disposed of there. This option entails, the third option, removal of the contaminated waste itself, the bags, the boxes, and the containers, treat it, possibly volume reduce the waste, and transport it to another CNL site for permanent disposal. The clay surrounding the waste, which we anticipate would have much lower levels of contamination, would stay safely in place, possibly with the addition of required barriers. This would be verified through careful sampling and testing. Before moving ahead, CNL would still need to obtain regulatory approval to confirm this approach meets all safety and environmental standards. If you recall from the pie chart earlier, unlike full removal, the total amount of waste would be much less and within the limits of a future disposal site, like the one at Chalk River would be able to accept. All in all, roughly 400 semi-trailer truck shipments, as opposed to the original, the other 3,000. Even with partial removal, some ongoing environmental monitoring would still be required to ensure the clay remains stable and does not pose a risk over time. This table summarizes how the three options compare. As you can see, each option has its advantages and drawbacks, and within each option, there are variations that could be explored as we proceed with the process. Whiteshell has a comprehensive environmental monitoring program in place to track conditions around the waste management area. This slide shows next slide, please. This slide shows the entire Whiteshell area, but as you can see, there's a great number of samples being taken around the waste management area near the top center of the picture. This includes regular sampling from wells that are located throughout and around the waste management area to check groundwater quality. We also take samples from ditches and other surface water pathways to ensure surface water remains safe. So far, the data shows that very minimal contamination has moved beyond the immediate waste management area, which is very reassuring. Though we can measure how the groundwater is being affected, the numbers are well within allowable limits, in the order of a magnitude of under 1% of allowable limits. To strengthen this work, Whiteshell is adding more monitoring points to gather even more detailed information on how contamination is being contained and managed over time. Now that you've heard about our low-level waste trenches, what comes next? To help us determine, get a clear picture of how the trenches are performing, and to help us determine what options may stand out over the others, last summer and fall, we embarked on a sampling campaign at the waste management area. We drilled 44 locations within the waste management area to collect both ground samples and install wells for water sampling. This data is vital to confirm which remediation options are practical and to get clear estimates of how much waste is present and the levels of contamination. We're planning additional sampling in the next couple of weeks to build on what we've learned so far. We will also build a model of the trenches using a number of geotechnical techniques to gauge water dynamics and possibly build a 3D-like model. As a next step, we'll continue engaging with everyone we've been engaging with so far to provide updates and share what we've learned and go deeper into the three main remediation options being considered. We want to keep these discussions going and dive deeper into each option. As always, your thoughts and feedback are extremely valuable to us. and we'll also keep you updated on environmental monitoring activities at the waste management areas, perhaps at future webinars. Okay, next slide, please. I know this was a lot of information to take in, but I would like to hear from you and what your questions are.
Okay, awesome. Thank you, Alan, for a great presentation. Yes, lots of information, lots of great work going on out at Whiteshell. So now we will take your questions. So yeah, just use the Q&A function and type in your question, and we will get to them. Let's see here. First question, how long will it take for all the trenches to be cleaned up?
All right, good. Yeah, good question. So we do anticipate that the project at the Whiteshell site, our remediation, will be wrapping up in the around 2035, somewhere in that area. We haven't selected an option. The time scale for each option would vary greatly. So depending if you're fully removing everything or doing selective retrievals, then that would certainly have an impact on the timeline. Also, different approaches. If you're remediating the trenches, would you be doing the 21 in series or in parallel with each other, which would also have an impact on the timeline. Though big picture wise, we anticipate it to be done within the timeline for the Whiteshell project, which we anticipate to be wrapping up in the mid 2030s or 2035 or so.
Okay, thank you. What types of tools and technologies are we using to create the digital models for the waste characterization?
So we did have some ground penetrating radar studies done. I think it was around 5 years ago. We're also doing some other techniques that induce an electric current in the ground between electrodes to measure conductivities and such, and then all that gets put into a computer. All that data would get stacked on top or layered on top of each other to build that model. And that model could help us get a picture without opening the trenches of what the trenches look like. Also would measure how water would be flowing one way or to the other, or down to different levels of the clays and sands and such. So there's number of different techniques that we're all using, stacking on top of each other to build that model.
Okay, thank you. Are there any concerns regarding water contamination during the trenches cleanup process?
So because the water table is high in this area, we do expect that the waste would have a certain level of water to it. We could expect it to be a little bit soupy. So while if we do choose to do any kind of waste retrievals, again, we expect that waste to be wet. And so it would have some levels of low-level radioactive contamination, as well as any chemicals that would have been put in the trenches as well. So part of the project is to get a water management plan, which may include pumping the water out, putting it to totes and treating it appropriately. Also, as the waste itself would be pretty wet itself, dewatering the waste would be an option as well. So it is on our radar and part of the scope. Yes.
Okay, thank you. Okay, this one's a bit of a long one. So the IEA defines 4 categories of waste: The fourth is very low-level waste. Given the radioactivity content of this waste, the IEA suggests that this waste can be disposed of in a surface landfill. Sorry. With respect to LLW, the IEA recommends waste be disposed of in a near-surface disposal facility. That said, the IEA does not recommend in situ disposal for LLW. So I guess the question is why that style of disposal?
So back in the 2002 environmental assessment that the Whiteshell project is based on, that was an acceptable solution back then. And because it was our project is still based on that, it is still within the scope of our project. So in situ disposal. However, this is why we're looking at different options, as in situ might not be um, an option moving forward, although it is still an accepted option. So this is why we're doing this rigorous characterization campaign. We're doing benchmarking at other facilities, both in Europe and North America, on how they're handling their similar installations as well. So this is all part. We're still in the evaluation phase on how we're going to be disposing of this low level waste.
Okay, thank you. Is there any risk of contamination migration to the Winnipeg River if the waste is left in place?
So this would be all part of the modeling for the safety case or safety assessment for all the three options. So all those will take into consideration migration pathways to the entire environment, including the Winnipeg River. So protecting the Winnipeg River is among the most important things that we do here. We really care about keeping the river safe. So each of the three options would be a consideration on how the river would be impacted.
Okay, thank you. Next question is on the assessments. What kind of assessments have been done to evaluate the long-term integrity of these clay dug LLW trenches, specifically considering how Manitoba's freeze-thaw cycles may affect the clay lining?
Exactly, that's a good one. That's what we're doing right now. The 44 sample locations that we took a drilling rig and did some core samples, installed wells, and that is to test the integrity of the trenches, of how they're performing. So knowing that there could be a variability of the quality of the clay, and then all the different layers. I'm not a geotechnical person myself, but I have a lot of them working with me. So, but taking all that into consideration, this is why we're enhancing our characterization campaigns. So our stage one, which we did last year, we did 44 into the clay, and measuring any kind of contaminant migration from area to area. The stage two that we're doing right now are we're going a little bit more deeply and intrusive. Subsequent stages, we will be possibly looking at doing some trenches, the sampling of the trenches waste, and also the liner and the caps. So that's what we're in the process of doing that right now.
Okay, thank you. Now lots of great questions coming in. Is the waste criteria limit based on radionuclide activities and dose rates? What is the dose rate limit for low-level waste?
I do not have that information at my fingertips right now.
Yeah, that's more of a radiation protection question,
Yeah.
but we can
right.
get some.
We'll respond to it in through our other
okay.
ways. Yeah.
Okay. why choose Chalk River facility to transport waste? So I can take that. So Chalk River, we've been storing waste, low-level waste, for decades and decades. We have the expertise, we have the proper people and handling and tools to safely handle low-level waste at Chalk River. So that's why it goes to Chalk River. How long will it take to fill up the waste container safely, Chalk River? I'm not sure of the timing, but that's why the waste is coming to Chalk River. If the in situ option is chosen, could an engineered membrane be installed under, or can you only control lateral contamination movement?
That's seen as one of the challenges for in situ, and if a liner is required to be underneath it, then there would likely need to dig the waste up or excavate it, prepare the area underneath it, and then place the waste or put the geomembrane and then the waste on top of it. So likely multiple handling of the waste. There may be other ways. Again, the grout wall and a cap to control migration in and out. This is why we are exploring the different options, is to see if, although in situ is still technically feasible, are there other ways? If we need to disturb the waste, would we need to put it back in, or what?
Okay. Thank you. Would your current plans allow for potential future nuclear development at the site? Probably a little out of scope, but
That's always an option. Right now, our mission is from our client, Atomic Energy of Canada Limited, is to close the Whiteshell site. But also the site would be ready for any kind of future development. This project, this low-level waste or waste management area, is operating as a waste storage facility, waste storage area. So we do still need to find permanent disposal solutions for all of our waste.
okay. Thank you. So I will. That's a lot of questions in a short period of time. Thank you, Alan, for doing all those, answering all those questions. So as the questions slow down, we'll probably start our exit here. So thank you for attending our webinar today. Before we wrap up, a reminder to please take the time to complete our follow-up survey. We'll be sending it out shortly. We'll send out the links to this recording and the answers to questions, that technical question and others we don't get to with the YouTube link. Feel free to distribute the link to anyone who may be interested. It takes about a week to get the videos up on YouTube and all the questions answered. And if you have any questions other than that, at any time, you can always get in touch with us at wlcommunications@cnl.ca. So thank you again, everyone, for joining us today, either for this webinar or the Douglas Point one we had earlier. Really appreciate everyone joining. And Alan, thank you for the great presentation and your expertise and answering all those questions. Really appreciate it. And stay cool, everybody, during this heat wave. We'll see you next time. Thank you.